This is the Titanoboa, one of the largest and deadliest snakes to ever exist. It went extinct 55 million years ago, but what if that never happened? What if the Titanoboa just kept evolving and was alive today? What special traits would this deadly creature have? And how big could it get? This is What If, and here's what would happen if the Titanoboa never stopped evolving. Okay, before we look at the modern day Titanoboa, we need to go back. 60 million years ago, the Titanoboa lived in the tropical waters of South America, arriving on the scene after the dinosaurs went extinct. It was a major predator of its time. This snake was unimaginably large. It had a girth of about 1 meter. That means if it were slithering on the ground toward you, it would come up to your waist. It was 14 to 15 meters long, and it weighed over 1,000 kilograms. Luckily, the Titanoboa wasn't venomous, but don't let that trick you into believing it was safe. It had a different way of killing its victims, by squeezing the life out of them. Literally, by wrapping itself around your body or squeezing your windpipe, and then swallowing you whole. And if you tried to slip out, you'd be met with rows of sharp little teeth that would dig into you. But you could see this creature coming, right? No, not a chance. The Titanoboa was the perfect color, a color that allowed it to camouflage itself in its swampy environment. It would sit and wait for the perfect moment to strike. It feasted mainly on fish, turtles, and crocodiles. So, if the Titanoboa was so dominant, what finally made it go extinct? Well, it had to do with a massive change in climate. But to understand this, let's first dive into what made the Titanoboa such a dominant creature, and then how it suddenly went extinct. Paleocene, 66 million years ago to 56 million years ago. Titanoboas emerged after the apex predator niche was left empty by the extinction of the dinosaurs. They thrived in hot and humid environments. Lucky for them, that's what Earth happened to be like 60 million years ago. The average temperature was around 24-25 degrees Celsius. Now, we love that temperature in the summer, but imagine if it were that way the whole year. Instead of ice caps, the poles were covered with forests, and instead of polar bears, there were alligators roaming around. Just like today, a planet even a few degrees hotter is very unpleasant for human beings, so it's a good thing we weren't around at that time. But there's a set of animals that thrive in the heat, cold-blooded ones. Our Titanoboa was cold-blooded, so it loved warm weather. Unlike warm-blooded creatures, cold-blooded animals aren't able to regulate their own body temperature. They use heat from the environment to warm up their bodies and kick their metabolism into a higher gear. So a warmer Earth was perfect for the Titanoboa. It had a supply of external energy to keep its body warm, hunt without mercy, and become one of the largest predators ever. But then the Titanoboa went extinct. Why? Well, a lot of changes were happening at this time. The Earth experienced two very different climate shifts. First, it became very hot, and then it cooled down. With our current evidence, it's not clear if the Titanoboa became extinct during the heat spike or during the cooling phase. So let's look at each change and try and figure out what might have happened. The heat spike event, 56 million years ago. It was 56 million years ago that Earth suddenly got super hot. The official name for this heat spike is the Paleocene-Eocene Thermal Maximum, or PETM for short. Massive amounts of carbon dioxide entered the atmosphere, raising the temperature by up to 8 degrees Celsius. The seas became really hot. In the tropics, it was like a warm bathtub with temperatures around 38 degrees Celsius. There was a mass extinction of creatures in the deep sea. In particular, many single-celled creatures called forams died out. Now, for the Titanoboa, this may have resulted in two different outcomes. It's possible that this giant snake thrived in hot water and became larger. Even if some fish were dying, other reptiles like turtles and crocodiles could have also grown big with the heat and became a great food source for the Titanoboa. So in this scenario, our Titanoboa just gets bigger and badder during the heat spike. But there's another possibility. Maybe the Titanoboa went extinct due to the warmer temperatures. Because the heat spike was so sudden, oceans absorbing carbon dioxide would have become more acidic. Many fish may have died in that acidic warm water, which would have meant fewer fish for the Titanoboa to eat. Now, if this were the case, the Titanoboa would have needed to adapt to survive. What evolutionary change could have helped it survive this heat spike? Well, if the tropical waters were too hot and acidic to live in, moving onto land would have been Titanoboa's best bet. Yeah, switching from a mostly pescatarian diet to being a meat eater. Now, as Earth became warmer, something interesting was happening. Above the waterline, the land was exploding with different types of mammals. Camels, horses, pigs, goats, and giraffes all evolved when Earth was a giant sauna. So, if Titanoboa moved from water to land, it would have found some new foods to keep it going. But because of its large size, living on land would have been difficult. So our Titanoboa would need a different kind of adaptation to get through this temperature spike. The giant snake is going to get some stronger swimming muscles and swim up to the poles, because now the poles have warmed up so much that they're tropical. The ice melted into water and the polar seas were full of crocodiles, the perfect lunch for a hungry Titanoboa. Eocene and Oleocene, 56 million years ago to 23 million years ago. Okay, after 200,000 years, the heat spike was finally over and temperatures went back to what they were before. But another major shift in climate is on the way, a cooling. Around 50 million years ago, temperatures began dropping in a long-term cooling trend that lasted until the dawn of civilization. The once lush forests at the poles are now becoming ice caps. This was bad news for the Titanoboa. The cooler climate didn't suit this cold-blooded snake. It could no longer get the heat it needed from the environment to be able to power itself. It's possible that this led to the Titanoboa's extinction about 55 million years ago. In order to survive, it would have had to evolve in a different and totally unexpected way. In our hypothetical scenario, the Titanoboa becomes warm-blooded. Maybe you're thinking, well, can a cold-blooded animal really become warm-blooded? Well, how is that even possible? Well, it's true that if we look at snakes, we don't see any examples of them being warm-blooded, but there is another category of cold-blooded creatures that have some warm-blooded exceptions. Fish. While the majority of fish are cold-blooded, about 0.1% are partially or fully warm-blooded. For instance, the moonfish is warm-blooded. Bluefin tuna, white sharks, and salmon sharks are kind of both. They use a special mechanism to raise their body temperature called vascular countercurrent heat exchange. Let me show you how it works. Let's use a shark as an example. Now, the muscles they use to swim generate heat, which heats blood in the veins. The arteries bring cold, oxygenated blood from the gills to the shark's muscles and organs. This cold blood picks up the heat from blood in the veins, which then raises the shark's internal temperature. But in the Titanoboa's case, there are no gills involved. It breathes in through its nostrils and has lungs to supply it with oxygen. But we can make it warm-blooded like the shark by having cold blood pumped in through the arteries, which then pick up the heat from the warm blood in the veins. This single evolutionary transformation would allow the Titanoboa to survive the mass cooling. Let's see what happens next. Miocene, 23 million years ago to 5 million years ago. During the Miocene epoch that followed, Earth began to warm a little, followed again by a period of cooling. The climate became drier and vegetation was more coarse. Rhinos were dominant in North America. Many species of horses evolved, as did a variety of camels. Also, a saber-toothed cat-like creature called the nimravid roamed around. Could the Titanoboa have adapted in new and different ways to spawn a line of desert Titanoboas? Yeah, I know I said that living on land would be tough for such a massive creature, but maybe there's an evolutionary path to make this possible. To camouflage in the desert, it would need to adapt a new color scheme, a light, sandy color. And its next most important adaptation? Strong muscles to burrow into desert soil and live underground during the day, both to conserve energy and to hunt under the cover of darkness. Now, to protect against water loss through the skin, the Titanoboa would take a lesson from the spadefoot toad. This toad secretes a semi-permeable membrane that makes its skin thick, locking in moisture. Our desert Titanoboa would branch out and have a new diet of birds and mammals. Many desert animals are too small to make a meal, so Titanoboa would lie in wait for a herd of camels, slither out of its burrow and make a killing. Or it might go months without food. So the evolutionary path of Titanoboas could lead to two subspecies. The first one is shark-like, swimming far and wide across the ocean, able to preserve its body heat through adaptations that make it warm-blooded. And the second is also warm-blooded, but lives in burrows deep in the desert, like the sandworms from Dune. They emerge from the burrows with lightning speed, only to strike, eat, and then retreat back underground. These 21st century Titanoboas would be as long as 23 meters and about 1.2 meters wide. Imagine going for a swim in the ocean and running into one of those. You'd have just enough time for one last breath. 6,000 years ago to today. Now, this brings us to the question of how modern-day humans might interact with these magnificent and terrifying creatures. Before the start of modern hunting, Titanoboas would have been legendary, frightening sea creatures that terrified humans. Our ancestors would probably be scared of going in the ocean. Who knows? Any swim could be your last if you encountered a Titanoboa. The only good news would have been that these enormous creatures would probably have little interest in eating you. Because humans would provide little sustenance, they'd rather catch a large fish or crocodile. That would be much more satisfying. Now, as humans developed better weapons, the relationship would have changed. There's evidence of humans hunting whales as far back as 6000 BCE. If the Titanoboa was still around, it may have been a target of fishermen thousands of years ago. Maybe these snakes would become part of our diet. If their meat was tasty, who knows? Maybe humans would have hunted them to near extinction by now. In today's world, it'd be a lot like the occasional shark attack. We'd probably hear about rare Titanoboa attacks on humans who swam too far out into the ocean. In the desert, nomadic tribes would probably fear the random, unpredictable attacks of the desert Titanoboa. Camels would have evolved to be super sensitive to those giant snakes' underground movements. Maybe they'd warn humans when they sensed activity underground. With infrared technology, we'd be able to detect the heat signature of Titanoboas in their underground burrows. Future. But in today's fast-changing world, something new and interesting would be happening. Human activity has reversed the cooling trend. With global warming, temperatures are becoming attractive for reptiles again. Our newly evolved Titanoboas have a warm-blooded inner architecture that has helped them survive the cooling of prior epochs, but as the Earth heats again, the Titanoboa would, once again, lean on the environment for heat rather than using its muscular inner activity. Conditions would be ripe for the Titanoboa to hunt even more effectively and grow bigger. As sea levels rise in future years, our coastal cities will be flooded and destroyed. The warm weather will help new generations of Titanoboa thrive. But the traditional habitats of the Titanoboa are currently being destroyed. The lush tropical swamplands and forests near tropical waters are being wiped out by logging and commercial activity. The growing acidification of the waters will kill the marine life that the Titanoboa feeds on. This would prove to be the biggest challenge for the creature, the destruction of its food supply. But there is one prey left for the Titanoboa. It would have to eat several to make a meal of them, but there's lots around. You guessed it, I'm talking about us. Maybe we'd become the target of the new ferocious Titanoboa. Watch out the next time a coastal city floods. Or maybe you should watch out for another giant creature, the megalodon. Those aren't still around, are they? Oh, that sounds like a story for another What If.